First of all, I'm a system architect of SiteGround for the past 10 years. I also organize OpenFest, Bulgarian Pro workshops, Linux Group Bulgarian meetings, and some other conferences. In my spare time, when I have some, I teach network security and Linux system administration in Sofia University. So, I have some experience with systems. Now, first, this talk may sound like a promotion for MySQL 5.7. It's not. Simply, it gives you more flexibility in what you can do. And a little disclaimer, because we have a lot of customers. We are one of the top 5 hosting providers in the world. And we have a lot of customers. And most of them run not very well designed software, including database queries. So I wanted to show you what you can do to your queries without actually writing all of them, and how you can optimize your usage of MySQL. In our case, 99.5% of the customers are using MySQL. Although I'm a PostgreSQL guy, I have to work with MySQL. So most of the information that I'll give you now is written in the documentation. Unfortunately, only a handful of people have read this. And I mean this part of the documentation. They have optimization part of the documentation, which is rarely consulted, and usually when the shit hits the fan, you go there and try to figure out something. So I'll try to prepare you for this. Yesterday I had like 50 examples of SQL queries in my presentation. Today I have only a few. Simply because it would take like 4 hours. This presentation was prepared for our internal usage before I decided to make it for the website. You need to monitor your databases. Usually most people are doing simply show process list and watching what's happening when the problems appear. If you don't want to do this manually, this is one of the rare times that I will promote proprietary software, but Marinov is your solution to monitoring your database. It gives you a lot of information and alerts that will give you insights about your usage of the database. And don't worry, usually the first time you install Marinov and you see what it will give you, you'll see around 90% full table scans. Don't worry, it's normal. So first, I'm sure that every one of you here is using indexes. But I'm also sure that half of you are using them wrong. Don't blame me. I just state statistics here. So we have some features in MySQL that most people don't know, like spatial indexes. Who here has used spatial indexes? Okay, 2, 3 persons, 4, nice. Most of the people that have used these indexes have used them for geometrical data. I will tell you that you can abuse this and not use geometrical data, but simply represent your data as a geometrical data and use these indexes to perform better queries on your database. Who has used the hash indexes there? Anyone knows that there is a hash index in MySQL? Yeah, so why we should use hash indexes? Usually it's nice for you to have it because if you have only a simple comparison if this exists or doesn't exist in your table, this is the fastest index that you can get. Because it's a simple hash, you either have it or don't. It also can be very useful for order by, and sometimes it's even useful for distinct queries when you have subqueries on certain fields in your tables. Hash indexes are not very used because most of the things that people want to do with the database are not precise queries like constants, like do we have ID of number 24 or something like this. If you want to have check if this name exists in your table, it's fine. You can use hash, but most of the times people are selecting select like name percent, and this cannot be done with indexes, with hash indexes. So they have limited exposure to your data, but they are extremely fast. Sorry. Also, you can use the hash. You can use B-trees, but with the B-trees, you have a lot of abuse there. So most people try to use B-trees directly with whatever they want. But there are rules to using this type of indexes. So they cannot be used when you're comparing two different columns. They're different type, or even if they're the same type. If their data is ordered differently, you cannot use the B-tree indexes for comparison. This is a problem. Also, when you're using like on these indexes, your like statement shouldn't start with percent, simply because this is a wildcard and you don't know where to start on the tree. You can have postfix percent, but you cannot start it with a wildcard. And also, you have to limit the size of your indexes because not you have, but you can. This is something that most people don't know about B-trees. You can have a bar chart field, for example, 100, but if you know that you need index only on the first 50 characters, you can create B-tree index that is only limited on these first 50 characters, which is quite nice because these indexes are not across all of your data, they're across all of your strings, but not across the full length of your strings. Also, recalculating smaller indexes is obviously faster. MySQL is using indexes most of the time. And there are a few times, we'll see now, when MySQL cannot use indexes at all. First, if you have created an index that is for a single column, or you have a table with 5 columns and you create an index for each column, MySQL uses a single index, usually when it is trying to optimize your query. So it tries to find the best index out of these 5 indexes. But if you have where clause which spans across 3 of these columns, it wouldn't use the first, second, and third column indexes. It should search for a single index that is covering all 3 columns. This is something that most people simply don't get the first time. They simply say, okay, I'll create an index for this field and for that field, and that's it. And when I query the table with both columns, MySQL will use only one of these indexes. It wouldn't use both of them. Then, if you create a query that is usually, for example, trying to query a string over a column that is integer, you wouldn't use the index at all, simply because this is a different type and it cannot convert it from string to integer. Usually this is not very obvious, simply because most people say, okay, I will never query my integer column with strings, right? Unfortunately, some people forget that there are quotes, and when you quote an integer, it's now a string, it's not an integer, and now you're not using your index at all. This is something that I hate, and I see all the time. People thinking that they have used an index, and they have created this index, and their query will use this index. Unfortunately, they use not equal. When you're using not equal, you cannot use any index at all. You can use hash indexes with not equal, which is smaller when you're using it with not equal like this, with hash indexes, but everything else cannot be used with any other index, cannot be used with not equal. This means that when MySQL optimizer sees your not equal part of the where clause in your query, it simply dumps all indexes and goes to password. Full table scan, and that's it. When you have multi-column indexes, a lot of people don't really know that if your where clause doesn't start with the first column of your index, MySQL will never use this index, simply because the fields are not ordered the same. So it's very important that when you have column 1, column 2, column 3 in your index, you use column 1, column 2, column 3 in your where clause. If you do even the simple thing of column 2, column 1, column 3, this index wouldn't be used. It should be the same. Also, if you're using, like, for example, only column 2 and column 3 in your where clause, and you still have the index for all 3 of them, again, MySQL wouldn't use your index. So this is a bit of, these rules you have to remember. This is a problem that cannot be solved simply by knowing that something exists there. You have to remember them every time you write a single query, because a single query can crash your database. When you have bit-trees in your index, but you use distinct on the column, unfortunately you cannot use the index simply because the B-tree can have nulls in it, and if you haven't defined the column as not null, it's not usable for MySQL because it actually cannot satisfy one simple requirement. Is this field null or not null? So it will go to full table scan. When you have single column index, usually you will get worse performance when you're joining with multiple columns. Most of the times, actually, MySQL will try to not use this index, even though its cardinality may be very good for you, it still wouldn't use it. And yeah, I've already told you about this. Prefixing alike with percent wouldn't work in B-trees. Yeah, the order matters, and this is something that I'll start to talk about. So we have this table that has so many rows. Normal query on this table takes 10 seconds. Now, without rewriting the query at all, simply adding hint to MySQL to which index should we use, we decrease first time the time for this query to 8 seconds, then to 6 seconds. And this is without actually writing the whole query, simply adding some hints to MySQL. Have anyone used index hints? Okay, I like that. So, first of all, MySQL may choose the wrong index simply because you have a lot of indexes for your table, but it's the wrong index for your query. It didn't match it well. So you can simply tell MySQL to ignore certain index. When you have more indexes, like, okay, I'll show you something here. Okay. I'm not sure if you can actually see this, but the query is this one here. And what I want to show you is the number of indexes that we have for this table. There are quite a few. So when you're using explain, you can actually see what's using here, what MySQL can decide to use. So the first thing is where we're using index, then we have again some index, and finally where. You can continue with this and the different optimizations that we get here when we ask MySQL to use certain index instead of the one that it actually chose to use here. So we're using a single column index. We're not forcing, but asking MySQL to use this index. What this means is that if MySQL optimizer decides that your proposal of using this index is bad, it will again override your decision with use index. And then finally, we have force index. Okay, no, here I have removed the force index. Here, use index actually worked when I chose different index here. We don't have enough time to cover the example here. If someone wants to talk more about this example after the talk, I'm available here. So we'll continue this. So use index gives you ignore index, removes some of the indexes that MySQL can use for its queries. Use index is a suggestion to the optimizer to use this index, but it can be overridden. And then we have force index, where we tell MySQL that we don't care about its decisions, we care about what we know it's right, and it should use this index. Then I'll return back to indexes later. Now we'll continue with the query cache. I know that most of you have heard about this MySQL query cache, and they're using it a lot. Unfortunately, it has some limitations, and this is when you have a lot of queries to your MySQL database. It's simply you have to acquire a log for each query on the query cache. So when you have thousands of queries hitting the query cache, they first wait to acquire the log. So now you see that even though you have query cache, you get worse performance simply because you're asking MySQL to use the query cache. And when you enable the query cache for your server, all of your queries go to the query cache. But some of your queries are actually very small, very fast, they're actually in memory. So they shouldn't go to the query cache at all. Then you get queries like this that have functions that require time. There are different functions that can trigger removal of the query cache. So this means that this query will never go to the query cache. The result will never go to the query cache because the next call to now will directly show you different number. If MySQL knows that this function that you're using every time is returning different data, it will never try to cache it. This again goes to random, to null, to a lot of functions. I don't remember all of them. And also you can put actual no cache in front, in the beginning of your select. This means that your query will never go to the query cache. It will never ask for a log. So it will be fast. It will stay fast because it's a small table. Like what I have seen is a table of 10 lines, 10 rows, nothing else. When the server is hit very hard by the read queries, selects, this simple select on these 10 rows actually takes 5-10 seconds. And these seconds are going directly to the query cache log. You can query the data, but you simply can acquire the log to check if it is in the cache. So, not very good. You can optimize these very easy by adding only this thing. You don't need to change your plan for your query. You simply add this. Then you have to know that this option is per query. So this means that you have to change all of your queries for your session. This is not very good. But you can apply it for the whole session by disabling the query cache type. So now when you have connected to MySQL, all of your queries for this connection will indeed cached. Unfortunately, this means that the queries that you really want to get from the cache wouldn't be cached, wouldn't be returned from the cache. So you have to compromise here. You have to find the balance between a single connection disabling of all of your cache, or disabling the cache per query for your problem. Depending on your software, on your usage of the database, it will be different. Then query cache is disabled as of 568. Why? It's disabled because the default storage engine is InnoDB, and InnoDB actually have additional cache. That is the InnoDB buffers. And sometimes, most of the times, the query cache is slower in returning the results than the InnoDB storage engine. This is why Oracle decided that it would be nice to disable the query cache by default and enable it only when you actually need it. Watch result sets, and here I'll give you an example. We had a client, we still have this client, that came to us. He was on a single machine, everything worked on his website. Then we created a distributed system for him, a lot of servers, and his web nodes requested all the data from MySQL over the network now. And what happened, what we saw was that this guy, for every page load of his index, he was putting 250 megabytes of data from MySQL for every page load. So what's happening is that the MySQL is fine, it can return the data, it's okay. The problem is that the network is not big enough. We were connecting him first on 100 megabits, then on 1 gigabit. Even 1 gigabit is not enough for this person for this type of usage. So we have to upgrade this guy to 10 gigabit network only to serve the data out of his MySQL. And the stupid thing here is that he actually didn't need that data at all. So there is a solution to this. Maybe he really needs this data, and he really needs these 250 megabytes of rows to each of his web nodes. So we added proxy SQL on each of the web nodes to cache the result set. We cache it only for 1 or 2 seconds. This is enough for most of his queries on the index page. So now, instead of pulling 250 megabytes on each query, we're pulling 250 megabytes every 1 to 2 seconds from each web node, which is a lot less. You can cache a lot of different queries by simply defining a regular expression for your query that you want to cache. But you have to define particularly every query. It's not like the MySQL query cache. You have to define what you want to cache. And be very careful what you're caching, because you can actually cache around. You don't want to cache, delete, update, insert, because these wouldn't reach the new IDs that you push, the values that you push wouldn't reach the server because you already cached the insert, which is strange, but you can do this very easily by simply deciding, okay, I'll do select.asterisk, but you have an update query which is update parenthesis select as and so on. So you see how easy it is to match with the regular expression update, even though you didn't want to do that. MySQL has different storage engines, and as InnoDB is the standard now, you have to know some things about it. MySQL can choose more than one index for your query. But when you're pushing down indexes directly to the storage engine, InnoDB will use only a single index. It wouldn't try to check other indexes. So the optimizer has the worst job here to decide which of all of your indexes should go to the storage engine. Index columns cannot contain any null values because this breaks the index. It's better to create a column that is not null, insert the data there. And if there is a column that may be null, declare it as null, so you know that the default values are these. This means that you're telling the optimizer that this column shouldn't have any nulls. And this is very important for checking which index is going to be most important for you. Because if the optimizer knows that you have nulls in certain column and you don't have nulls in another column, the column that doesn't have nulls may be optimized out simply because other rules of your where statement dictate that it's not possible to have both nulls and non-nulls in your result set. InnoDB also suffers from walking overheads. So it's a good idea when your queries are actually only read queries. You really know that there is no array based on this select that you're doing. It doesn't use any built-in function or your own function procedure that changes anything on your data. You should start your transaction with start transaction recon. This means that you're telling InnoDB, I'm not changing anything. Don't worry. Don't try to acquire a log for this table or for that table. I'm simply reading. So this changes the way MySQL uses optimizes your query, and also changes the path your query takes to the storage engine. About MySQL now. A lot of us are still using MySQL. Some things that most of us don't know. I didn't know that before, I think, November last year. You have to tell MySQL regularly that it needs to analyze the table again. What this does is checking the indexes and checking your data, and also creating statistics for your table. These statistics are very important for the optimizer. These statistics include information about how many rows you have in your table, what's the cardinality of all of your indexes currently, what is the biggest column on your data set, how many holes do you have in your data. So a table with removed rows from it in the middle are holes in the table. So this gives insights to the optimizer to decide which index would be more appropriate for your queries. So running this on your tables regularly is required now. This is something that in PostgreSQL is done automatically, but with MySQL you have to do it manually and regularly for MySQL tables. You can also do it with MySQL check. Then the other thing is MySQL has a problem with the data that you're storing on the disk. What's happening is you created the table, and your queries were perfect, your indexes were perfect, and 3 months later, you now have queries that are querying most of your table by the second or third index that you created, and your data is actually ordered by your primary index, the first index. The order of the data on the disk, I'm talking about this, on the hard drive. So your queries get your data, but the storage format is not optimal now, because you're querying your table based on your third index. So what you can do is you can use MySQL check and to tell it to reorder the data on the disk based on one of your indexes, and you're simply telling the index number. So if it is the third index, you simply say query here. This is I/O intensive operation, so keep it. Try it first on the backup servers before you do it on the live servers. It may crash your MySQL when you're doing this. And by crash, I'm not telling you that the MySQL daemon will die. You will simply have a lot of sleeping queries, a lot of waiting on your queries while you're doing this. So try it first on our table. Avoid very complex select queries on MySQL tables, simply because frequent updates on MySQL tables usually block the whole table. So when you have complex select, it will block on different parts of your MySQL tables that you have selected. So try to keep it as simple as possible with MySQL. For complex data, complex joins and stuff like this, you should go with MySQL. How many of you know about concurrent inserts? 1, 2, 3 people? So MySQL supports concurrent inserts similar to what MongoDB does, but it's a hack. So you can append to the back of the table simply by default they are disabled. By default they are auto detected. If it is possible, it will use it. So how this is done? If your table doesn't have holes in it, missing rows in the middle, you can insert concurrently to the end of the table without a problem. So this auto means that you're detecting if you have any rows missing in your table, and then inserting, appending to the back of the table. If you this here should be 2, sorry. The last one. So always means that even if you have deleted rows, you are asking MySQL to append to the table, append only to the table concurrently. This means that when you have selected this option, and this is an option for your session, not for your query, this is an option for your session, you set it up, and you can issue multiple inserts that can be concurrent. If you have 2 sessions that have concurrent inserts enabled, actually both of the sessions can concurrently insert in the same table. What was it? Yeah. Try to avoid bar chart, blob, and text in MySQL. I know that most of you are using that. If you remove these 3 types of columns from your MySQL tables, you will get constant static definition of your tables. If you add even one of these columns to your table, now it switches to dynamic storage, which means that you may change very easily to change the order of the fields in the data file. You may change not only the order, but the types that you have in your table, and this will not change anything in the data file. While when it is static, when you're running canvas table, this also may rearrange the data on your disk for optimal usage. And here I have to tell you, most of these things, they are optimizations for rotational hard drives. So most of you know that when you hit the limits of I/O on your machines, you simply request SSDs. And these optimizations now are somewhat useless, simply because SSDs can handle thousands of IOs per second and random IOs also. With MySQL, it's not a very good idea to split one large table, large by the number of columns that it has, to split it in smaller tables. Why? Because MySQL is optimized for disk seek, so when you're not using SSDs, with normal hard drives, you seek to the data on the hard drive, and then you get all the data. So even though you may not use all the data, you're now on this particular place on the hard drive, and you can get all of your data or simply one or two columns of your role. So splitting this would mean that after you get these two columns, now you have to create to seek again to a different place on the hard drive and get the rest of the data. Now I will contradict with myself with this statement in a bit. Now finally, who has used delayed writes here? Nobody? Oh, one person. So the delayed writes. When you're creating the table, you can actually tell MySQL that you want to write the indexes later. So you're updating or inserting or deleting from this table. Usually this requires a lock on your table and then update on your index. Okay, this is fine, but your indexes may take a while to update. When you have, for example, 10 or 15 indexes, I have seen tables that have more indexes than columns. So when you update these indexes, it takes a lot of time. And you cannot actually finish your query before the indexes are updated. With delayed key writes, this means that your indexes will be written later on. There's a small problem here. If your MySQL crashes before it actually pushes the new indexes to the hard drive, you would have to reindex when you start MySQL next time. But compare this with the performance that you get, it's better to use this delayed key writes. Also, you have to know that you're not losing the data, you're losing the key. So, okay, performance will be a little bit worse when MySQL crashes and you're recovering it, but you should have a spare one. This is the main part of my presentation. This is what you can do to optimize, to tell MySQL what you want to actually do with your query. Unfortunately, the part that is in bold is only from MySQL 5.7. I'm sorry. Even I'm using 5.6 on most of our machines, and I'm considering upgrades for these things. So you can change how the optimizer is taking its decisions by simply telling it what you want, by using this optimizer switch option. You can select it per session, and I'll try to explain some of these things, not all of them. First, multiple index counts. When you have a single index and you have holes in it, so you have removed some rows from your table, what's happening is that MySQL will first scan the index to the first part, then seek to the next part of the index, then seek to the next part, and so on. So sometimes this is not very useful because what you have given as a where clause creates like 1,000 different sub-index scans. So it's not a single index scan, but like 1,000 different index scans. So when this happens, MySQL may simply decide to throw away your key and start using your full table scan. Since I don't get enough time and I have like 15 more slides, you can disable the merge of those index scans and simply do full scans of the index. You can define the algorithm that you can use for these index scans. And keep in mind that your indexes that don't actually match most of your columns, not columns, rows, definitely slow down the intersect algorithm. Batch key access and nested loops, you can change the way optimizer is using your queries for joins. So first, both nested loop joins are simply full scan of all of your tables based on the where code that you have given. But if you use batch key access, you can batch these from the outermost query to the innermost query, meaning that the outermost query may select like 10 or 1,000 rows and give those rows to the most inner query in your join. So what will happen is you will get better performance because all the lookups inside the loop are done from memory. This doesn't work for all of your queries, so you should check if batch or block nested are better join optimization for you. This you can tell the optimizer to do. Materialization is a scheme for optimizing by simply creating temporary tables. You can disable this. And for temporary tables, I don't have this in the presentation, put them in the TML5S. You can create temporary file system which is in memory, so all of your temporary tables are created instead of the hard drive in memory. So now you get the performance of the memory without the overhead of the hard drive. Exist strategy is used every time you have nodes that have to be compared in joins. So in joins with subqueries. Sometimes maybe you would want to disable that and try to do it materialization because it's faster. You can control it with this.
And I can control it with this.
Yeah.
Finish already?
Yeah. 1 minute.
Like 10 seconds.
Yeah. This is for security. You need to read this paper because all of your transactions are broken. I mean, thank you.